Hi there. Welcome to this CSA virtual event around AI, this AI summit. I'm Aaron Turner, longtime cybersecurity guy floating around the industry. Been working a ton with the IONS research team and IONS customers to understand what does all this AI stuff mean. And I'm here to talk to you a little bit about not only do you think about AI in one way, but what is it that we think about when it comes to thinking about lots of AIs together? What does that mean from a risk perspective? How can you threat model infinite non-determinism? Maybe, I don't know. So what I'm going to do is I'm going to walk you through my approach of how do we define our new reality? What do we think about understanding scale and scope of that new reality? I'm going to talk about a multi-AI security architecture that I've been working on with a couple of consulting customers. And really, I'm going to talk about we've got to come up with new stuff. Like we're in an age where innovation is going to be required. There's not one thing to say, hey, do it this way. This stuff is moving so quickly that we're going to have to move with it. And so be prepared to move that way. So first, let's take a moment to think about the past. I had my first real exposure to global scale problems when it came to Slammer and Blaster, right? So back in the 1990s, Microsoft had a vision. Uh, every host can be a file server, and every connected device can have its own database. And what ended up happening was you you ended up having SQL servers and file servers everywhere, and when someone did bad things to them, it made me lose literally years off of my life. Like there were times when I had to sleep on floors and I wasn't able to see my family for weeks at a time, trying to clean up the mess that came from everyone was a file server and everybody had a database, and those things got attacked. Well, if we think about where we're heading relative to the future, well, everyone's a vibe coder now. We have we have MCPs for everyone. We have agents everywhere. And so I think that we've got to be ready for some really bad things to happen. So let's talk about a framework that luckily CSA has been really promoting and helping to build, and that's Maestro. So back then in the late 90s when we were dealing with Slammer and Blaster, myself and others at Microsoft, we had to help create this thing called Stride. Stride was a threat modeling framework that you could use to sort of say, hey, what can we do to understand the badness of this situation? Well, today's version of Stride is Maestro, multi-agent environment security, threat, risk, and outcome model designed for AI. And it's maintained by the Cloud Security Alliance. You've got different layers. So layer one, foundation models. Two, data operations. Three, agent frameworks, deployment in our infrastructure, evaluation of observability, security and compliance, and then an agent ecosystem. And so using this framework, we can start to hopefully make sense about where we can focus our efforts. And so, for the purposes of this conversation, I'm going to focus on MCP because I think that's really the background of why we're having this multi AI conversation. So, for those of you not familiar, MCP it is a way for AIs to work together in a client server architecture. It's designed to give AI clients or agents the ability to connect to all sorts of different things. So each MCP server it exposes a tool description, something that it can do for the agent or it can do for the user. And things like read write files or query a database or act like an API to a code repository. It gives you parameters of like what it will speak. What are my input fields? What data types can I use? What are the constraints? It gives you the supported operations, whether the tool supports read, write, or other operations. And it gives you the opportunity for metadata for information like versionings, authentication requirements, and transport protocols. And so an example workflow would be, I'm going to connect Claude to an MCP server designed to give me access to a GitHub repository. And so what happens is Claude can send a JSON RPC request, say, this is who I am, JSON RPC 2.0 method, get tool description, gives it an ID. The server then responds to say, okay, I can either create an issue or read a repo. What do you want to do? Repo URL, auth token, that sort of thing is what you can ask for. Then the agent can then parse through that to go, okay, is this helpful or not? Do I not want to talk to this MCP server? And so The problem that I have with MCP is it was written by people who didn't have adult oversight when it came to security. So, and I helped write new stuff back in the mid 90s. I was very passionate about email. And so I was on the crew that helped write the IMAP 4 standard. And every week we would have a new standard, IMAP 4, version whatever, and we'd try this out. But in the background, there were these graybeard dudes. We called them graybeards. Generally, people who were working for AT&T, like the people that I was working with were mainly Bell Labs type people. And they were the ones who would hold us accountable through an RFC process, right? And that RFC process is what drove discipline into protocols like IMAP 4. Well, unfortunately, that didn't happen when somebody at Anthropic, I don't know who it was, basically came up with MCP in November of 2024. And it was released without any security capabilities. In fact, a quote that I love from one of my friends, Jake Williams, is like, if someone tried to violate and counteract every aspect of the Stride threat model, MCP, mission accomplished. Like, seriously, the first version was awful. But now, there are others who are doing other things, but while Google and OpenAI have competing efforts, I think we can say that MCP has sort of taken front and center right now with the way that it's working. Now, there is still some danger of bifurcation or fragmentation, like a VHS versus Betamax moment, but I would say most of the enterprises I'm working with have settled on MCP for their interconnectivity. Now, implementing an MCP server is not designed for performance. It's designed for helping you do things across a diverse set of data or a diverse set of tools. So the thing that I do ask folks when I start talking about MCP servers is like, do you really need an MCP server, or do you just need to enable the agent to make an API call to data? Like, MCPs are good for multi-data connections, not for one-to-one. You don't want to add that overhead. So there's also an aspect where when you're using other people's MCPs, you have to subject yourself to the lack of threat modeling they're doing. And so an example of what I've seen in certain situations is with ServiceNow. They've deployed their Now Assist module. This is an agent that helps support teams to improve incident handling. And in some cases, they pitch it to say, hey, we can help users become more self-sufficient so they don't need to open up a help desk call, or they can have better access to a knowledge base to help them self-serve their things. Well, in one demo that I was doing with ServiceNow, I asked the sales engineer, I was like, hey, will you run this query? And I said, which user has reset their password the most over the last year? And it came back, and it was actually the chief financial officer, the CFO of the company, was the one always forgetting their password or whatever. And what that does from an attacker perspective, it says it basically helps you triangulate. Like if an unauthorized user were to gain access to an MCP session on ServiceNow, it could serve as targeting information of target this person for phishing or target this person for credential replay attack. Another serious situation we saw in this once was where curious users were starting to ask questions about hardware assignment details for anyone involved in a discrimination proceeding, basically trying to bypass the controls around HR data by asking the MCP for fronting the ServiceNow instance, hey, has anyone here had a piece of hardware confiscated because of child porn or sexual harassment or whatever? And unfortunately, it's come back and said, why, yes, this person was involved in that. So sometimes you have to worry about the unintentional leakage of data from these MCP servers. So if we think about how Maestro can help with this, so in layer 3, it has an agent frameworks module, which basically is designed to look after the logic, protocols, and toolkits for the agent behavior. And its core purpose is to basically act as a standardization way to say, look, this is the way I'm going to make you put things together. But it also helps you think about, well, what happens if an element of my chain, my tool chain, gets poisoned? It also helps you be disciplined to say, I'm going to do things like protocol validation, secure transport, formal verification of MCP endpoints, and that sort of thing. So that's where we can focus to say, how does Maestro give us the framework to work? Layer 3 agent frameworks is where we can focus for MCP deployments. Now, if we think about the MCP security risks that are out there, and this again comes from a CSA hosted list called the top 10 security risks for MCP servers, We've got things ranging from prompt injection, confused deputy scenarios, tool poisoning, credential and token exposure, insecure server configuration, supply chain attacks, excessive permissions, data exfiltration, context spoofing, and insecure communication. So if we think about how can we solve these things? Like, if we can only do three things, what are the most strategic things we can do to go after these vulnerabilities? And it might not be the intuitive way, but let me walk you through some ways that I've tried to herd what I call the MCP cats. So, first, it is my opinion that you should treat MCPs as malware if they try to run on endpoints. Because when someone runs an MCP server local, and not to cast aspersions at any particular user group in particular, but generally it's the folks rocking a MacBook that's outside of MDM or EDR coverage, and someone decides to install an MCP server on their system to potentially team with others to do something interesting, working on a code project or whatever. And so someone installs their MCP server, they turn on a listening port, now people can interact with that. Well, now all of a sudden that MCP server is running under the user context of the Mac user, which means that the MCP server has access to all of the Mac users' data, which could include their entire OneDrive system and other things that they may have access to. So that's something you want to be careful about. So my first suggestion is hunt and destroy MCPs using your EDR platforms. That should be step one. Do not allow these MCPs to run in uncontrolled compute environments. Now, you also want to make sure that you create clear guidance about where MCPs can execute. So not only is it the blocking, but I call this the strategy of turning on a porch light on the back porch, where you can attract the bugs. You're attracting the moths and the flies and the mosquitoes to say, hey, I have this cool place where you can do MCPs really easily. And by the way, you've created really firm DevOps pipelines to go, hey, this is my dev test prod scenario for MCPs, and here I can work with a major cloud provider to know which MCP servers versions that I can support. And so with several consulting customers, I've gotten interesting traction with AWS Bedrock as a release management and a controlled MCP environment. And so I think that's something that you can look at to say, I'm going to make a bet on my destination for cloud. What can I do to provide appropriate MCP governance in that context? Because I tell you what, you're going to have much better instrumentation and telemetry with things like guard duty and other AWS monitoring capabilities in Bedrock than you will in other places. So make sure that you avoid homegrown MCP builds. You stick to the appropriately released and supported MCP versions from a major cloud provider, and make that the place where you can do things well. Now, there's an aspect of this where you also have to provide a certain level of performance and SLA promise to those individuals and say, look, not only have I implemented my security controls here so that it protects me, but I'm doing this in a way where all the cool stuff is available for developers to test out the full capabilities of what MCP can do. And so sometimes you have to lean into risk to say, this MCP function, I'm not quite sure how I think about it, but you know what? Because I'm monitoring in my centralized environment, I'm going to let people take a risk and we'll figure it out later. So that's the sort of thing that we've got to do here is we've got to meet developers where they're at when it comes to this technology. We have to focus on authentication and logging at every step. So what about prompt monitoring? Well, what about Purple Llama? Well, what about all this stuff? You know what? A lot of that stuff is still not quite baked. So what I'm going to do is I'm going to focus on authenticating everything I can, logging everything I can, and I'm going to figure that stuff out later, right? So sometimes I'm moving so quickly, I don't have a perfect pipeline for monitoring prompts as well as responses in a way that may make me comfortable in the initial case. So if we think about where can you go to learn more? So OpenAI has an MCP guide, Cloudflare has an MCP guide, and I should pause there. Well, wait a second, Cloudflare has an MCP guide. It is so interesting to see their perspective of MCPs as sort of an API gateway that you have to protect, just like you protect an API gateway. And so I love what Cloudflare has done to basically take their perspective on anti-denial of service, web application firewalls, all the stuff that Cloudflare does, and applying that to the MCP world. And I think there's something valid there. AWS, GCP, and Azure all have MCP server guides as well. Would highly recommend that you go take a look at this documentation, get smart about that. Now, let's talk about a security architecture that I've found that works. So I would say, and as of September, which was the last release that I've played with, I have not found what I would call true native full stack security in MCP, which means that I'm going to go back to the future with my architecture here. So what I'm going to do is I'm going to focus on the maturity of the tools like load balancers, API gateways, places where I can log and monitor along the steps, and then also reinforce it with other compensating controls like Spiffy and Spire. So for example, let's start at the top of the stack here. We've got an MCP client, whether that's a Claude agent or someone's writing a web app or whatever. So first, my rule is every time someone interacts with an MCP server, they must have an OAuth token. OAuth is my table stakes for authentication. SAML won't cut it. I don't want anything crazy like Kerberos. I want an OAuth token for every time you're interacting with the MCP server. Next, I'm going to say, okay, what's the destination for this? So I'm going to do my duty to make sure that I don't suffer denial of service here. So I'm going to put up a load balancer or some web application firewall that does TLS termination. So I have an SSL connection between the agent and where it's heading. I can then strip out, after the load balancer, I can strip out the OAuth token to go, hey, is this person authorized to be here? Yep, looking good. I've properly scoped that token so that I can take it and forward it on. And so once I check the scope, then I'm going to forward it off to my identity provider. They go, yep, this looks good. The MCP server then receives it, and you want to make sure that all of your OAuth tokens are designed for what's called constrained delegation. Now, constrained delegation is a concept that when I was back at Microsoft, we first came up with for the purposes of Kerberos. And so it was something that we used to say, I'm going to track the entirety of a user session from the moment that they log into their system to the moment they go to this web app front page to the moment that they're hitting the database on the back end. And I've got consistent traceability of that user session because of a constrained delegated token. Same thing holds true for OAuth. I'm going to take that OAuth token, and when the MCP server goes to make the database call that it needs to do, then at that point, I can use the OAuth token against the database, and I now have consistent logging of that user identity from the agent to the load balancer to the API gateway to the MCP server and to the actual data store where it's interacting, or whatever tool the MCP server may be fronting. Now, you can see that down there in the bottom left-hand corner. You've got log aggregation, SIM, and anomaly detection. Critical that you get those things plumbed from the beginning. You've got to get those pipes set up so people can actually monitor what is going on here. Now, I mentioned some things that I think are important for compensating controls, and those are tools like Spiffy and Spire. So Spiffy and Spire is a mutual TLS design system. So basically, you're issuing certificates at a very rapid pace. So for example, there's a TLS certificate for the client. There's a TLS certificate for the MCP server. And let's say you're rotating those every day or every week or whatever. Those are ephemeral certificates that are being used as part of a short-lived, secure, verifiable identity. Right? And that becomes the element. So in this case, you would have a Spiffy capability that's issuing certs down to the clients, to the MCP server, and you now have mutual authentication at the TLS level for all of those connections, and you have mutual secrecy, right? So auth plus confidentiality, that gives you in a much better state, which makes it harder for someone to come and do things like destination poisoning or trying to spoof a backend or whatever. You've got mutual auth and observability for all of those connections, plus you're sending the OAuth tokens through, so you essentially have two factors of identity for every single jump that the inter-AI stuff is making. And so you think about identity issuance for MCPs, identity issuance for databases, identity issuance for microservices, right? This is something that's truly scalable that can help you do that work. So what do you need to do? You need to understand the scope of MCP usage in the organization. Where is this stuff happening? Use your EDR tools. Hunt for MCP as if it were malware. Next, focus on one MCP environment. Build it well, and the people will come. Build appropriate controls within that one environment. Wait for auditors and business leaders to hold developers accountable and herd the cats into there. And constantly look for innovation partners. Who can help you with this? So, hopefully, you found this session valuable. Would invite you to connect with me on LinkedIn. I'm publishing things there. You can interact with me there. Feel free, get connected, follow me there. I appreciate this opportunity that CSA has given me to talk to you a little bit about what I see the future is when it comes to multi-AI security. And hopefully you enjoy the rest of the summit.